All right, I want to do an example now of hydrostatic force or fluid force. Um, Remember that the density times the depth times the area is the force. The thing is, the depth is changing. So what I need is a variable. And in these problems, I really like to set my variable up with y equals 0 at the top and y equals whatever my depth, my total depth is at the bottom. So this would be y equals 6. So y is actually measuring the depth. It tells you how deep you are. There's some people that would start with y equals 0 at the top and go upwards, but you just have to be careful then because y is not measuring the depth. It would be, if y was starting at 0 here and going to 6 at the top, then for any particular value of y, the depth would be 6 minus y. So I just find it more convenient on these problems to set it up with y equals 0 at the top here. So I'm thinking about, I got this whole dam here. It's it's all the way full. So I'm slicing the whole thing up into these horizontal slices. Each slice is all this area is at the same depth below the surface. It's at the depth, whatever y is. Right? So to calculate the total fluid force, I have to say, what's the density? Well, the density, I'm in feet here, so let's use 62.5 pounds per cubic foot times the depth. The depth is y, times some area now. The area is the area of one of these little rectangles. Of course, that's going to change with y. You got shorter rectangles here, you got longer rectangles up at the top. Okay. So what I need is thickness times length here. Well, the thickness is definitely a dy. And so what I need now is a function that tells me how far across this is. And I want to do this by, let's call that length L. Essentially, I make it, with all the straight sides, I can just tell this is going to be a linear function that gets bigger as y gets smaller, I guess. But what I do is I look at it and I say, I know that when y is equal to 0, so this is the y-axis, this is the l-axis. When y is equal to 0, the length across there is 3 feet. I also know that when y is equal to 6, down here at the bottom, so when y is equal to 6, then the length across there is 1. And I'm looking at this saying, well, I need a straight line that goes through those 2 points. Well, that looks like for a run of 6, I've got a rise of -2. So it looks like the slope is equal to -2 over 6, which would be -1/3. So this would tell me that L is 3 minus 1/3 y. 3 minus 1/3 y. Do a double check. Plug a 0 in for y. This would be 3 minus 0. That's 3. That's what I want. And when y is equal to 6, down here at the bottom, 6 times the third is 2. 3 minus 2 is 1. Now all that's left for setting up this integral is to figure out what values of y am I interested in. Well, I'm interested in wherever there's water. I have water from depth 0. Why did I write y 0? I went from 0 to 6. This would be the force pushing against that dam. I now need to do the integral. This wouldn't be too hard to multiply this out, but I'm going to opt to use my calculator. And my calculator tells me 1,875 pounds of force pushing against that. Let's take another example. I'm going to call this one the milk and cookie example. What's going on here? There's a big jump that happens. Oh, I see. I'm going to the next page. Okay. So, I've got a round cookie that is submerged under the water. Let's, for the sake of argument, say that this is down 1 inch and that the cookie has radius 2 inches. I want to know how much force is being applied to one face of that cookie. This would be important to know because we don't want the cookie to crumble. We need to make sure the cookie can withstand the force of the milk. For the sake of this one, let's say that the density of the milk, it's a little more dense than water. So let's say 64, actually, I think is what I want to say. 64 is the density of the milk. This would be pounds per cubic foot. Okay, cubic foot. So, I need a coordinate system. Now on this one, I'm going to opt for a different coordinate system because of this circle here. I'm going to need to know a distance across for each value of y. It's just simpler for me if I think of the circle as having the equation x squared plus y squared equals, I'm not going to say 2 because this is going to be in feet, so this 2 inches is 1/6 of a foot, so 1/6 squared. As soon as I do that, though, I've just placed a coordinate system with the origin at the center of the circle. So y is measuring 0 right there, and it would be 1/6 right here at the top of the circle, and then an inch above that, that would be 3 inches total, which would be a quarter of a, so this would be y equals 1/4 at the top of the water there, okay, or the top of the milk in this case. So the depth now is going to be whatever y value I'm at, the distance from the top down to y. So that would be the, sorry, why did that jump? The depth is 1/4 minus y. Right? Quarter of a foot is what the top and down to whatever y value you are at. Okay. The thing is, though, I always do this by taking horizontal slices so that I can figure out an area times the density times that depth. And the distance across is going to be the x value on this side minus the x value on that side. Well, using this equation for the circle, I know that the x value on this side is the square root of, actually I'm going to write it down here, x equals the square root of 1/36 minus y squared. That's what it is on this side. On the other side, it's the negative square root. X equals minus the square root of 1/36 minus y squared. Okay. So, the distance across would be this one minus that one, and the distance across would just be 2 times this one. I mean, this is measuring from 0 out to there, and you got it twice. So the distance across is 2 times the square root of 1/36 minus y squared. The thickness of that little slice is dy. So that's the area. Now I need to multiply by the depth and the density. And then I need to add those all up for everywhere that I have cookie, right? We're pushing we're pushing on the top, we're pushing here, we're pushing in the middle, we're pushing down on the bottom. So this was, so 0's right here. The bottom would be at minus 2 inches, so that's a minus 1/6 to plus 1/6. And I had to convert to inches. If I done that, I converted to feet, I mean, everything's in feet. And the density is in pounds per cubic feet. So, okay, I'm going to go to my calculator now and see what it says. And after a bit of thinking, my calculator says 1.396 pounds. I'm inclined to think that I shouldn't take too many decimal places because with the length of time it took my calculator, there's an issue that somehow it was having trouble getting appropriate accuracy. I'm guessing that the problem is because of the nature of circles, that this, well, y is my variable here, so I'm looking at slopes kind of sideways, but this would be this would normally be a slope of 0, but because of having y as my variable instead of x, this is essentially a vertical tangent line on the ends. And I think that's messing with the integral here, making it tough to get an accurate one because the calculator is doing it numerically. Anyway, I'm reasonably confident that at least the first 3 places are are good. My point on this one is, often you want to let y equals 0 on the top on these problems and do y is just the depth. If you do that though, then yeah, this would be a y right here, but this would be a different formula because of what the equation of the circle would have to be if 0 was here, right? This would be shifted down 1/4. So actually, let's try that. If you had the y equals 0 at the top, and you had this here, so that's the center is now 3 inches down, the equation of that circle would be x squared plus y minus 1/4, quarter of a foot squared equals 1/6 squared. Right? So when you're solving for that distance across, you need the x value on this side, the x value on that side. It's going to be 2 times, well, square root, but instead of having a y here, you're going to have a y minus 1/4. Also, the integral is going to be from whatever the y value is there to here. So this would be 1/12, and then plus 4 inches, right? 4 inches, 4/12 would be 1/3. So you'd go from 1/12 to 1/12 plus 1/3, whatever that is, 5/12. So yeah, 1/12 to 5/12 with a y right there, and then a 2 minus a square root. With, instead of a y, it's a y minus 1/4. So just depending on the situation you're in, you might want to have y in the middle, particularly, I think, with y equals 0 in the middle, particularly with circles. I think this is the way to go, to put that in the middle. It's your choice. Whatever coordinate system you choose, stick with it.